is by substitution. It is not the best way. It is a better way. Okay, does anyone know what the word substitution means? What's substitution mean? Like, what's your definition? What do you understand substituting to be? Chelsea.
Like you substitute, like in a sports related, like one person comes out.
Oh, okay. That's a good illustration. You have a guard in basketball, and you substitute one guard from the bench with the guard that's on the floor. They switch places. Now that person's the guard who came off the bench. He or she is the guard. What else? It's a fill-in, yep. In January, my wife is expected to give birth to our daughter. I will not be here when that happens. Who's going to be here in my place? I don't know who, but it's going to be a substitute. And in that illustration, listen up, in that illustration, that person is going to be up here. They're going to grade your homework. They're going to teach a lesson, and they're going to give homework. Even though they're not exactly me, they're acting in my place, right? They are the teacher. They are the math teacher for whatever time that's going to be, right? It's a substitute, taking the place of. Those illustrations are pretty good, but they don't reach the illustration for substitution with math. Math is not this person is acting in place of that other person. It's an exact this person equals this person. And the best way I can think of it is this way. And it's cool because you see it in the Bible. Adam gave birth to Adam fathered Seth. Yeah, he didn't give birth. Adam fathered Seth. And what's cool about what the Bible says about it, it says Adam fathered a son, Seth, in his image, in his likeness. I'm like, whoa. That's how God created Adam. The closest I can get to that is my son Ezra, my oldest. Obviously Titus and my daughter coming up. But let's just use Ezra. He is in my image. He is in my likeness. That's weird. He is like a little Mr. A. He may sound like me. He may look like me. And even scarier, he may act like me. That to me is like, please don't do that. That's weird. But if he were somehow, we would go to like a time travel machine. And during that time where I'm out with my wife, he comes in to teach. You can almost say that Mr. A was substituting for Mr. A. You know what I mean? It's basically Mr. A coming in, different Mr. A, 2.0 Mr. A. He is in here in my place. It's like a one-for-one substitute. 2.8. 2.8. That illustration, as some of you are saying, it's not working really, really well for me. There's a better illustration, and this is where it goes. When we're born into this world, what kind of hearts do we have? Sinful heart. And guys, this is not easy for me to say because I just had our son Ezra, our son Titus, and now my baby girl's coming soon. They come into this world as sinful people. And trust me, they are sinful. Like, there's no doubt in my mind, Ezra's sinful. Titus is sinful. And even when I hold my baby girl, and she's not going to let out all her sin at once, but little by little, she's going to show it off. What does sin deserve according to the Bible? Yeah. Okay, God's word says if they sin, my two sons and daughter, or you, or me, we deserve to die, right? But who takes our place? Who is our substitute? So instead of me dying on the cross and me dying in eternal death, who substitutes in my place? Jesus Christ is right there. And it is as if I were on the cross and I take the eternal punishment. That is the perfect way to use the word substitute. And it's actually the mathematical way of looking at substitute, because I deserve to go on that cross. I deserve to take the full punishment of my sin. But what does Christ do for me? He comes in my place and He takes it. That is amazing. And we get to talk about it through math. Now, if you trust in Jesus Christ and you repent of your sin, that substitution is valid. If you reject it, it doesn't apply to you. That's your choice. And by God's Spirit, I pray that all of you have accepted that substitute, that payment that you deserved. And again, guys, I'm not just saying you. I'm saying me, and I'm even saying my little kids. My kids that I love so much. If they don't accept that substitute, they will go to hell. They will be separated from God. So I do that. I say that because I love you guys. And I'll say it to my kids over and over and over because I love them. So that's the idea. So I just want to talk about that because that's substitution. Okay, this is how we're going to apply it here in math. We're going to deal with a system, but we're not going to deal with it in the same way. So go ahead and write this down, please, because we're going to have to work this out. How do I know that this is a system of equations? Yeah, you have the brace. Good. That's a system. How did we work these out yesterday? What did we do? We solved each of them, got them either slope-intercept or standard form, and then what did we do with them?
Put them on the graph.
We put them on the graph, see where they intersect. Today, we are going to move away from the graphs. We're going to use this method called substitution. Okay, how many variables are in this problem altogether?
4.
Okay, I could say 1, 2, 3, 4, right? I could say there's a y, an x, and a y. Do you guys realize that this x and that x are the same? You guys understand that? And whatever that y has got to be the same thing, right? Do you guys agree with that? Because if you don't agree with that, we're lost on this problem. Okay, I said these x's are equal to one another and these y's are equal to one another. Okay, and I think you guys agree with it. What does y equal? Y equals... It equals 3 times whatever x is plus 2, right? Do you guys see that? I mean, it's right there in the equation. I'm going to use substitution and this fact to help me to solve for the variables. Ready? Look at this bottom equation. What does y equal?
3x plus 2.
Yeah, it's 3x plus 2. So instead of y, you know what I'm going to actually write in and substitute? So write this down. 2x plus 2. And what does y equal? I know.
3x plus 2.
3x plus 2 equals 28. I just substituted 3x plus 2 for y. Is that valid according to this problem? Is that logical, rational, allowed? It is. Now you're looking at this and saying, well, why would I do that? How many variables do I have in this problem? 2, but technically I really only have 1. Can you solve for x up here? Go ahead and do that, and you can work it out with me if you need help. I'm going to use basically a distributive property here. What's 2 times 3x? 6x. What's 2 times 2? And that equals 28. So I just used distributive property there. Are there any like terms that combine or add, Sophie?
2x.
That gives me 8x. Right? These two give me 8x plus 4 equals 28. How do I solve for x? From both sides. Good. I get 8x equals 24. And then what do I do to both sides to finish it out? Divide both sides by 8. And I get x equals 3. Okay, I got x equals 3. That's a good question. If all I have is x equals 3, I don't have a point. What else do I need for a point? I need a y.
So you substituted that.
Wait, I already substituted, right? I did this substitution. But don't I know what x is now?
3.
Do I know what x is? I know exactly it's 3. So what I'm going to do is I'm going to substitute 3 in for either this x or that x. Which one do you think I should use? The top x. Okay, ready? Here's the substitution. What's 3 times 3? 9 plus 2? What does y equal? What's the ordered pair then? 3, 11. That's correct. That's the ordered pair. That's your answer. Ooh. No more graphs required. Yes, ma'am.
Why did you do the top equation instead of the bottom? Is there like a specific reason?
Okay, yes. I used the top equation for y because y was already solved for. You see how y is already by itself? So I know exactly what y equals. It equals this. And this is where I have to get into my... Now I have to branch off from here. Sometimes the first y is easiest to solve for. Sometimes the first x. Sometimes the second x. Sometimes the second y. Sometimes it doesn't matter. Sometimes it really matters. Sometimes it can matter. Sometimes it won't matter. I don't know which one's the easiest one to solve for. It depends on you. What I'm going to teach you right now, guys, is that any one of these would be able to work for substitution. But some are really easy and some are really not so easy. So we have to, this is what we call wisdom. And for me to say, all right, Molly, here's your thought process. You need to think this, then that, then this, and that, and then that. Then you get your answer. That's hard because that process applied for that problem, but the next problem, sorry, Sydney, now it's this and this and this and that and this and that, and then this. And then Josh, the next problem, this, then that, then this and this and that. Oh, don't forget that one. There. So it's where you're starting to use your thinking. You have to be able to look at a problem now and say, all right, if I go this route, if I solve for X or Y in this exact, what's going to happen? Oh, that's bad. I don't want to do that. I'm going to try another way. Some of you are going to be like, I want to choose that one, and you choose it. Oops, that was not the right way. Or that was hard. And then some of you are going to be able to say, I know that one's bad, but I'm not sure between these two. I'm going to pick that one, and it didn't come out as bad as you thought. So it's going to take a lot of trial and error.
Just say even pick the smaller equation.
I'll give you some hints. Yeah, I'll give you some hints. Any questions? Yes, ma'am?
I'm still confused on the substitution part. Like,
Yes, we've done it once. I'm going to do it more times here. But let's do this here. I did promise one graph. We're going to graph this. I know. I have to graph it too, by the way. Can you give me the two equations real quick? We're just going to do one graph today. One graph. Yes, ma'am? The original ones.
The original ones?
Yep.
Y equals 3x plus 2 and 2x plus 2y.
Okay.
Find the slope with the...
Yeah, you can do negative a over b and and c over b. Yeah. Okay. What you're going to do with your graph is you need to go up to 14 on the y-axis on the positive side, and then go up like 5 and 5 on every other side. So here, 1, 2, 3, 4, 5. I went up 15, but at least 14. So one more graph today. And I want you to graph both of those on the same coordinate plane. The first one, what form is that in? Do you guys remember? What form is y equals 3x plus 2? Slope-intercept. All right, what's the intercept? So I put a 2 up here. And then what's the slope?
3 over 1.
So I go 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. Or 1, 2, 3 over 1 this way. And, oh, thank you. I'll take that line. So that's what the first graph should look like, right? How do you graph the second one? Well, what form is the second equation in?
Oh, wait, that one.
Yep, second one. Standard. So I'm going to get from standard the negative a over b. What's the slope?
Negative 1.
Yeah, it's negative 2 over 2, which is negative 1. What's the y-intercept? C over b, 14. See why I wanted you to go up to 14? Anybody? That way? Somebody?
C.
Okay, good. So I start at 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And what's the slope there? Anybody? Someone there?
oh, negative 1.
Yeah, negative 1. So I go down 1 over 1, down 1 over 1, down 1 over 1. Where do they meet? Or where should they meet? What was our answer when we used substitution? 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Did they meet there? Could you have found the solution by graphing?
Yeah.
Yeah, you could have. Do you have to use graphing? No. I'm going to give you a problem where you would hate me if I asked you to graph it. And I would hate myself for asking you to graph it because I have to check that graph, and it's awful. But are there other ways to solve systems of equations? Of course there are. And so that's how we can solve it, two ways, substitution or graphing. Okay, write this new one. This is a new one here. We're going to do substitution again. Again. Practice it. Get better at it, I hope. Okay. Here's a question you want to ask. The answer to that question depends on you. It depends on you. How many variables could I solve for? 4. You notice that these two x's are the same, those two y's are the same. Out of those 4 variables, x, y, which one do you think is the easiest one to get by itself? So, is this x the easiest one to get by itself, or this y the easiest one, this x, or that y? Which one? Your pick. No, I want to hear your feedback. I don't know. It's you.
I don't know either.
It's your, be you. You know how to say that. Like, be you. Okay, be you here. Be me. Be that. Okay, sorry. Who wants to give me a suggestion? They want to.
Top one.
The top what? X or Y?
Y.
Okay.
Top X.
Okay. Any others? Who says the top Y? Who says the top X? Listen, for me, the top X would be the easiest. Why? I mean, how? That's where I had to watch what I say. How? What? This X is almost already by itself, isn't it? What do I have to do to get completely by itself? Subtract 4y from both sides. That's all I have to do. Ready? What should I get? So I'm rewriting it. All right. I want to solve or get x by itself. So what do? Subtract 4y from both sides. I get x equals 7 minus 4y.
Would you do that before you did anything else?
Yep, just get one of the variables by itself. Yeah, I would suggest that. There are many other ways to do it. Man, I'm not kidding you right now. I can spend hours on how to figure these out. Hours. All right, let's do it this way, guys. All right, let's challenge you. Let's do it this way. Let's see what way you want to do it. Fine, we'll do it that way. And hours just spending on this. But this, I think, might be the easiest way. Yes, ma'am.
Does it matter if you put negative 4y plus 7?
Good question. So I put 7 minus 4y, and maybe some of you are thinking, well, Mr. A, can't you say this? What do you think?
No.
Yeah.
Yes.
I'm getting your feedback. It's the same thing. Some of you really hate this, and some of you hate that. Do the one you don't hate, or test yourself and do the one I don't know. Just you pick. Both of them are the same. I'm going to use the one I wrote down first, just because. See, I'm not saying you have to use this way, but I'm just going to use that way. But you could use the other. Okay. Do you notice that I solved for the first x? Okay, and I got it right here. X equals 7 minus 4y. So I can say quite literally that x is exactly the same thing as 7 minus 4y. They're the same thing. How do I know that? Because they equal one another, right? They equal. They're balanced. Whatever x is, it's the same thing as 7 minus 4y. Okay, I'm going to now use this equation. And instead of x, what should I, ready? Substitute it with?
0.
7 minus 4y. Why would how would I do that? Like, what reason do I have to do that? Don't these two equal one another? So instead of x, I'm going to put in 7 minus 4y. So ready? 2 times 7 minus 4y minus 2y equals 9. I just rewrote the second equation, but instead of x, what did I put? Sorry, it looks like I got shot at a few times. It's been used a lot here. All right. Yeah. So what happens here? Instead of x, what did I substitute? Don't be afraid to say that. 7 minus 4y. Yeah, you can say negative 4y plus 7. Yep, same answer you'll get at the end. All right, can I solve for y here? Do it. Yeah, distribute property here, right? Because you have these parentheses, and you're like, I'm going to distribute. 2 times 7? Yes, 14. 2 times negative 4y? Excellent. Negative 8y. Minus 2y. You guys are doing great today.
Thank you.
You guys are on top of it.
We're trying.
Yeah, I know. See, that's a sad thing. I know. No, you're good. You're
Do you
good.
want to get y by itself?
Mm-hmm.
Okay.
The last one.
If you solve for x, you want to get y by itself? Do you see what I'm saying?
I see what you're saying, but really, if you solved for x at first, you're going to substitute x with whatever you got, and that means now you can solve for the other variable, y. So yeah, you're solving for x, then solving for y. In this case, that's how it's going to work out. Y? Yes, y. Oh, wait, y? Y or y?
Why?
Be clear with me, man. You know, again, this is my, 8th year, and I love making jokes with y. Why?
Why?
It's y. Oh, I can keep doing that. Okay, but I'm done.
Okay.
I'm going to subtract 14 from both sides. Here I get 14 minus 14 is 0. Eliminated. Negative 10y equals, what's 9 minus 14? Negative 5. What do I do to both sides? Divide by negative 10. And be careful here with the division.
Want to be 1/2?
Yes, it'd be positive 1/2. Can it be that one of your coordinates is a fraction? Is that allowed?
Yes. Unfortunately.
Unfortunately, if you were graphing it, because if you were graphing it, wouldn't you have to try to see, wait, is that 1/2 or 2/5? I don't know which one it is. Now you know exactly what it is. It is exactly 1/2. Yes, ma'am.
So now,
Yes, now. Substitute it. Or substitute.
So now what do we do?
Get ready? No, that's a good question. Do we have what y equals exactly?
Yes.
Okay, now which one do we need to get next? Okay, do I know what this y equals? Do I know what this y equals? Do I know what that y equals? Which one of those would really help me to get x quickest or easiest? The first equation, second equation, or dare I say the third? Third, this one. This equation right here would help me, so I'm going to substitute one more time. I'm trying to find what x is. But I don't know what x is. I know what y is. Right? I do know what y is. It's 1/2. So here, what's 4 times 1/2? Yeah, this would be right here. This ends up being either 7 minus 2 or 7 plus negative 2. But you get this right here. 2. This is 2. And what's 7 minus 2? What does x equal? What's my ordered pair?
5.
Where does that graph, or where do those lines, I should say, intersect? 5 1/2.
How do you say 5 is this?
Oh, because here, I did 7 minus 2 is equal to 5. So I guess to make it clear, no, because I don't usually do this, you're right. Like that. Okay. I don't know about that answer. Looks weird. I'm not graphing. No, I'm done graphing. I'm done graphing. Personally done graphing. Like, I don't want to graph. Shouldn't it work for this one and that one? All right, ready? What does x equal?
5.
What does y equal? What's 5 plus 4 times 1/2?
7.
5 plus 2 is 7. Check. It works, but it doesn't have to work for both. What's 2 times 5? I'm going to write that down for my own good. What's negative 2 times 1/2? Negative 1. What's 10 minus 1? Check.
Yay.
It fits both of them because of this fact. Ready? How many solutions technically are there for the first equation? Technically,
1 and 2.
infinite. Remember, this is a line. How many solutions are there for this line? Infinite. How many solutions are there for both at the same time?
2.
1. All right, let's see if you guys are thinkers or non-thinkers. I'm just going to leave it like that.
Oh my gosh.
I really want that thing to follow me.
Jake. I didn't graph, did I?
Jake, this is uncle.
But what I want you to do, Jake, is imagine these graphs. So imagine the lines. I don't know, somewhere there. Where do they intersect?
It's a half and 5.
They intersect at 5 and 1/2, right? So 5 1/2. Jack,
Yes, sir.
are these lines consistent or inconsistent?
Consistent.
How do you know that?
Because I can look back at my homework and you said that was the answer and it's like the same thing.
Okay, this is why you know. How many answers are there to this?
3.
2
One.
incidents.
One.
So there's at least one answer that's consistent. Are these two lines independent or dependent, though?
Independent. Yeah, independent.
They're independent.
No. They're independent.
Okay, they're independent because they're not the same line. Are they the same line?
No.
How do you know they're not the same line? Because there's only one solution. Remember, how many solutions are there for the same line?
2.
Infinitely many. Is that infinitely many?
No.
No. So
Wait,
it's
how do you find out if it's infinitely many?
if they're the same line. You'll figure those out later, not today. It's going to be very clear. Oh wait, that's infinitely many just by the equation. And also no solution. But we're not there yet. All right, let's do this one here, guys. One of the things I want you to be super careful with, Josie, is when you write down these problems on your paper, you want to make sure you write it exactly the way it was stated. Do not try to shorten it or go really quickly, because sometimes you know what happens? You get these two equations, you work them out, you did everything right, your answer's wrong. Totally wrong.
Then how did you do it? Right, wrong.
Exactly. You wrote the problem down incorrectly.
Then it's not right.
No, it is. You did the work right. Your work is perfect. But the problem was wrong. So you just wrote down the wrong problem. But you did the right work. So you did all this good stuff, but it's wrong because you wrote the problem down wrong. What a shame. What a shame. Okay, which one of these variables do you think I want to solve for? Which ones do you think I want to get by itself? Which one's the easiest one, Mandy?
X.
The first x. Why is it the first x? It's almost already by itself. It's almost already solved. Yep. So I'm going to take that one. Shouldn't I just subtract 2y from both sides? Okay, I'm going to get this. X equals 14 minus 2y. Isn't that what I get when I subtract 2y from both sides? Okay, so that's what I did. You can also say x equals negative 2y plus 14. Go.
So now would you put the X in the first one or the second?
Thank you for that question. We use the first equation, right, to solve for x. So now you have to substitute in the other equation. Yes, so please don't solve for x here, and then you get this, and substitute it back into the first one. You're going to get an answer that's always right, even if you're wrong. Now that's a mystery. Don't ask about that, but you're not going to get the final correct answer because you're going to get something that's always correct and that's wrong. Oh man. Am I speaking in riddles and enigmas? Okay. Good, because that's what I'm trying to do. Yes?
So when we're solving, let's say we do it the first equation, when you're always doing the first equation and you get x by yourself, that's when you substitute x for the second
equation. Yeah, and if you try to solve the second one, let's say you substitute back into the first
So
one.
if you're solving for 5y, you substitute the y answer in the 2y?
Yes, sweet. Yep, that's exactly it. Yep, that's good. Okay, instead of x here, what should I put in?
14 minus 2y.
Because x is equal to 14 minus 2y, I'm substituting. So 3 times 14 minus 2y plus 5y equals negative 40. Can you solve for y? Go ahead and solve for y, if you haven't already. We'll pretend that didn't happen. The strange noises that come from you guys.
Max.
No.
Can I combine these two together? So I get 42 minus y, or minus 1y, equals negative 40. Okay, what do I do to both sides? Subtract 42 for both sides. Yes, because I have 42. I'm trying to get y by itself. So that cancels out. I get negative y equals negative 82. Oh my goodness. What does y equal though? 82. I don't want what negative y is. I want what positive y is. So I divided both sides by negative 1.
Okay, but I don't.
Ready?
No.
Imagine if I had to graph that. So do you guys remember when I was graphing 14 up there on that y-axis? I got to go up to 82.
Go by 20.
You can go by 20s or 10s or 40s, 80s. Okay, and then you still mess up because you have to go down 1 over 2. Do I like graphing, guys?
No.
No. But do I have to know how to graph? Of course you do. And just realize that it gets tough.
There's a hair on my pencil.
Yes, ma'am. Sorry, Bill.
Well, I understand how you get the first,
Awesome.
but I don't understand how you get the second.
Okay, ready? I'm going to explain that again. Do I know what y is? Yes, it's 82. Okay, what I'm going to do is I'm going to say, I want to find out what x is. Oh, I don't mind if you keep going. Okay, here I want to find out what x is. How do I do that? Well, don't I already know what y is? Which one do I want to substitute with 82? The last one. You know why the last one? Because if I plug it in here, or substitute it right here, figuring this out will give me x's right away. So here, x equals 14 minus 2 times 82, right? It's because y equals 82. What's negative 2 times 82? 164. And what is 14 minus 164? Imagine having to graph that. Now listen, that's where they intersect. So you can start at the origin, you go negative 150 to the left, and then you go up 82. That's where they intersect. But is that where you started your graph? This is uncomfortable, by the way. You would have had to start at that y-intercept and gone, and then from that other y-intercept, and somehow got it. Do we like graphing? No. What's my solution, Cole?
Negative 150.
So you got to write it like this. That's your solution.
Sure, I thought we didn't want to have a negative though.
Sorry?
I thought you didn't want to have a negative.
No.
No.
You have negative 1.
Yeah, you don't want a negative variable equaling something. But you can have negatives. Yep, you're going to have a lot of negatives. Look on page 155. We just did number 1. Look at it.
Oh, we did. What do you mean?
Oops. Look at it. Look at it. Look on page 155, number 1 on try these.
Oh. That's a lot of words.
Tell me.
Oh, we
You made us put
did.
negative
Yeah. Mr. A.
I didn't write it down correctly.
Mr. A.
Hey, hold on. Didn't I do all the work well? I mean, isn't it all good? Doesn't that work? Listen to me. Listen.
You just broke my brain.
You were just telling us that we had to pay attention to what we were writing down. You're doing this on purpose.
All right, listen carefully, guys. Listen. I gave you this problem. You worked it out and you got this. You are correct. But Mr. A wrote the problem down wrong. Oops. It's a little minor mistake. It's a negative sign. What happens to the answer? Way off. Way off. But did you work it out correctly? Yes, you did. Be careful. Don't do that. All right, we're going to do number... No. Listen, no, this is good that you still worked it out. It's not like it's bad. It's just make sure you check it. Don't worry, I'll make up for it. Write this down, guys. Number 2. Did I write it down correctly before I do it?
What? Yes, you did.
Yes.
Okay, yes, ma'am.
We did not go down to the bathroom. It's an emergency.
Okay, let's keep going here. Which variable would be the easiest to solve? And this time, guys, it's up to you. I don't know which one's the easiest to solve for you. For me, it might be this. For you, it might be that. We have different reasons, but we'll still come out to the same thing if we work it out carefully. So, if you want me to work it out a certain way, you better raise your hand so I can consider it.
The second equation,
So, the second equation, which variable, though?
2y.
So, the y?
Yes.
Anyone else? Yep. The bottom x. Anyone else? I'm taking votes here.
Top y.
Top y. Okay. Last one. Anybody? Jack?
Bottom X.
Bottom x. I got 2 for the bottom x. 3.
Top x.
1. You voted again. Yep.
Top y.
Top y. Oh my.
Bottom X.
Why, oh my.
Bottom end.
I'm going with the bottom y. I'm going with what you don't. Okay. The whole point I'm trying to make here is it doesn't matter which one. As long as you do it correctly, you should be fine. So please listen to me. Listen to me. Some of you could have solved for the top x, which, by the way, is the easiest one to do. Top x.
I told you.
Some of you would have done the top y, some bottom x, some bottom y. It doesn't matter. I'm going with bottom y, just because that's the one none of you voted for. Come on, that's sad. Okay, anyway.
I voted for it.
Oh, okay, gotcha. Now.
I voted for 0. I voted for top X.
I think we should do number 2.
All right, I'm solving for y, so I'm going to subtract 2x from both sides. And I'm left with negative 2y equals 1 minus 2x. Do you guys remember? I hope you guys remember something. Doesn't this look like I'm trying to get standard form into slope-intercept form in a sense? Do you guys remember that? Is this standard form? Is that standard form?
Yes.
When I divide everything by negative 2, don't I get y equals negative 1/2 plus 1x? Doesn't that kind of look, if I flip these around, wouldn't that look like slope-intercept? Hello? Anybody?
Yes.
Does that look like slope-intercept? Yay! Have we done this before already? Yeah. The reason we go through standard slope-intercept point slope is because we want to prep you up for substitution. Imagine that. Okay. I'm going to use the original one. Do I know what y equals?
No. Yes.
I do. It's right there. Which equation did I use to solve for y? Top or bottom? Stay with me. Top or bottom? Bottom. So which one am I going to substitute it into? Top. Just stay with. Finish this up, guys. 3x minus 6 times negative 1/2 plus 1x equals 0. And is that tough? Yeah, but you guys can work that out. All right, I reduced the homework load, and they had 1 minute. You have no minutes. Sorry. 1 through 6 all. Number 1 was done for you. 5 problems.
What page?
5.
What page?
Okay, 5 through 6 all.
Like
Straight with page.